Hello, and welcome to Boring History for Sleep. Tonight, we drift gently into the unassuming world of supermarket operations, focusing on a component so fundamental, so ubiquitous, yet so thoroughly overlooked that its very existence often goes entirely unremarked upon. Imagine a quiet morning in an American supermarket, perhaps in the bustling post-war era of the 1950s. The gleaming aisles are ready, the shelves stocked, but before the first customer arrives, a subtle dance of maintenance ensures a smooth shopping experience. At the heart of this seemingly simple operation lies a complex, often overlooked component, the shopping cart axle. What secrets do these humble wheels hold? And how did the silent, tireless effort to keep them moving smoothly evolve over half a century, often without fanfare or even conscious notice from the very people who relied upon them daily? To truly understand its significance, we need to examine its origins and the painstaking efforts to perfect its lubrication, transforming what might seem like a trivial detail into a subject of surprising historical depth. Our journey begins, appropriately enough, in the early 1940s, a period when the modern American supermarket was still finding its definitive form. The shopping cart itself, while patented by Sylvan Goldman in 1937, had only begun to gain widespread adoption. Early carts were often simpler affairs, less robust than their later counterparts, and their wheels, while functional, were not necessarily designed with longevity or sophisticated maintenance in mind. At this nascent stage, the concept of a standardized lubrication method for shopping cart axles was largely non-existent. Supermarket proprietors, or their designated maintenance personnel, if such a role even formally existed beyond general handyman duties, would typically employ whatever lubricants were readily available for general mechanical purposes. This often meant simple petroleum-based oils or greases, applied manually and intermittently. In these early days, the lubrication of a shopping cart axle was a task that might be performed with a rudimentary oil can, similar to those used for bicycles or small machinery. A worker might simply drip a few drops of light machine oil onto the visible axle shafts where they met the wheel hub. This approach, while straightforward, had numerous limitations. Light oils, by their very nature, possess low viscosity, meaning they flow easily. While this allows for quick penetration into tight spaces, it also means they are prone to dripping away, evaporating, or being displaced by water and debris. Consequently, the lubricating effect was often short-lived. The wheels would begin to squeak or drag again relatively quickly, necessitating frequent reapplication. This was an inefficient use of labor and lubricant, and it contributed to a generally shorter lifespan for the wheel assemblies. Grease, a more viscous alternative to oil, began to see some use even in these early years. Grease, fundamentally, is a solid or semi-fluid lubricant consisting of a thickener dispersed in a liquid lubricant, typically a mineral oil. The thickener acts like a sponge, holding the oil in place and releasing it slowly over time. Early greases were often calcium-based, derived from animal fats or other organic compounds, possessing limited temperature stability and water resistance compared to later formulations. When used, it would typically be applied by hand, perhaps scooped from a communal pot with a small spatula or even a gloved finger, and smeared onto the visible moving parts. The effectiveness of this method was highly dependent on the skill and diligence of the individual applying it. Without specialized fittings or tools, it was difficult to ensure the lubricant penetrated effectively into the internal bearing surfaces. The exposed grease was also a magnet for dust, dirt, and stray fibers from the supermarket floor, leading to abrasive contamination that could accelerate wear rather than prevent it. The 1940s were marked by wartime austerity and the rationing of resources. This meant that specialized maintenance tools and high-performance lubricants were not always priorities, or even readily available for commercial enterprises like supermarkets. Durability and cost-effectiveness often took precedence over optimal performance in the long term. Shopping carts were utilitarian tools, and their maintenance reflected this pragmatic ethos. A squeaky wheel might be tolerated for a while before a quick squirt of oil was administered, or it might be replaced altogether if it became too problematic. The concept of proactive, scheduled maintenance, particularly concerning lubrication, was embryonic. It was more reactive, addressing issues as they arose rather than preventing them systematically. As we move into the 1950s, the American consumer economy began its post-war boom. Supermarkets grew larger, and the number of shopping carts required for a single store increased dramatically. This heightened usage put greater strain on the carts and their components, making the inefficiencies of earlier lubrication methods more pronounced. A significant development during this decade was the gradual introduction of more sophisticated wheel and axle assemblies. While many carts still featured simple bushings, essentially metal sleeves that allowed the axle to rotate, some manufacturers began to explore rudimentary bearing systems, often loose ball bearings or roller bearings, though not yet fully sealed. The advent of these slightly more complex wheel assemblies necessitated a more refined approach to lubrication. It became increasingly clear that merely smearing grease on the outside of a bushing or dripping oil onto an exposed axle was insufficient. This period saw the rise of the grease fitting, most commonly the Zerk fitting, named after its inventor, Oskar Zerk. These small, hardened steel nipples, designed to accept a specific nozzle, allowed for the injection of grease under pressure directly into the bearing cavity. This was a significant leap forward. For the first time, maintenance personnel could ensure that lubricant reached the internal surfaces of the wheel assembly, displacing old, contaminated grease and providing a fresh layer of protection. The tools for applying grease through Zerk fittings were also becoming more common. The lever-action grease gun emerged as the standard. This device consisted of a cylinder filled with grease, a plunger, and a lever mechanism that, when actuated, forced the grease out of a nozzle and into the fitting. Using a grease gun was a more controlled and efficient process than manual application. It reduced waste, minimized contamination of the lubricant, and, most importantly, delivered the grease precisely where it was needed. The type of grease also began to evolve. While basic calcium-based greases persisted, the 1950s saw increased availability and adoption of lithium-based greases. Lithium complex greases offered several advantages. They provided better mechanical stability, meaning they resisted breaking down under shear forces, and possessed a higher dropping point, allowing them to perform effectively over a wider range of temperatures. They also offered improved water resistance, a crucial factor in environments where carts might be exposed to rain, snow, or cleaning solutions. The choice of lithium grease was often a pragmatic one. It was a good general-purpose lubricant, suitable for a wide variety of applications, including the moderate demands of a shopping cart wheel. Despite these advancements, standardization was still elusive. Each supermarket chain, and sometimes even individual stores within a chain, might adopt its own preferred methods and schedules. Some might embark on regular, perhaps monthly or quarterly, lubrication cycles, while others continued to operate on a reactive, fix-it-when-it-squeaks basis. The impetus for better lubrication often came from the manufacturers of the carts themselves, who might include recommendations in their maintenance manuals, or from the growing awareness among supermarket managers that well-maintained carts contributed to a better customer experience and reduced replacement costs. A smoothly rolling cart was not just a convenience, it subtly communicated an image of cleanliness and efficiency. The labor aspect also became more defined. Instead of general handymen, some larger supermarket operations might employ dedicated maintenance staff, whose responsibilities included routine cart inspection and lubrication. Training for these individuals, however, was often informal, learned on the job. The technique for using a grease gun, for instance, involved understanding how much grease was enough without overpacking a bearing, which could lead to excessive heat or bursting seals, though robust seals were not yet standard. The subtle art of applying just the right amount until a slight resistance was felt, or until a small bead of fresh grease appeared at the seal, was a skill acquired through experience. Moving into the 1960s, the supermarket landscape continued its expansion. Store sizes increased, and competition became fiercer. Efficiency and cost control were paramount. The shopping cart, now an indispensable part of the retail experience, was subject to these same pressures. This decade saw a gradual but noticeable shift towards greater reliability in cart components, including wheels and axles. Manufacturers began to offer more robust wheel options, often featuring stronger steel construction and, crucially, a greater prevalence of sealed or semi-sealed bearing units. The introduction of sealed bearings had profound implications for lubrication methods. A sealed bearing, by design, contains its own lubricant and is intended to prevent the ingress of contaminants like dirt and moisture, and to retain the lubricant for the operational life of the bearing. For many shopping cart applications, particularly the front swivel caster wheels, which endure the most stress, these sealed units were a significant improvement. They reduced the frequency of required lubrication, in some cases eliminating the need for periodic regreasing altogether for the lifespan of that specific component. However, sealed for life often meant sealed for the life of the average shopping cart wheel, which, under heavy supermarket use, might still be considerably shorter than an industrial bearing. For unsealed or semi-sealed components, particularly the fixed rear wheels, which might still rely on bushings or simpler bearing arrangements, the grease gun with Zerk fittings remained the primary method. The 1960s saw a refinement in grease formulations. Manufacturers of lubricants began to offer specialized greases with enhanced properties. For instance, greases with molybdenum disulfide, moly, or graphite additives, known as solid lubricants, started to gain traction. These additives provided an extra layer of protection, particularly under boundary lubrication conditions where metal-to-metal contact might occur. While such high-performance greases were more expensive, their use could extend the life of a wheel, reducing replacement costs and maintenance frequency. However, the use of these more specialized greases for shopping cart axles was not universally adopted, often deemed an unnecessary expense for what was still considered a relatively low-tech application. Lithium complex greases continued to be the workhorse. The concept of a preventative maintenance schedule began to solidify in larger supermarket chains during the 1960s. Instead of waiting for a squeak, maintenance teams would perform routine checks and lubrication on a set schedule, perhaps every 3 months for all carts, or more frequently for high-traffic stores. This systematic approach aimed to minimize downtime, extend the life of the carts, and ensure a consistently smooth customer experience. Such schedules required accurate record-keeping, a log of when each cart or fleet of carts was serviced, what components were lubricated, and what type of lubricant was used. This increased formalization of maintenance practices represented a subtle but significant evolution from the ad hoc approaches of earlier decades. The challenge of environmental factors also gained more attention. Shopping carts were frequently exposed to the elements: rain in parking lots, snow and ice in colder climates, and the abrasive grit from asphalt and concrete. Water resistance in greases became increasingly critical. Lithium complex greases, with their inherent water-resistant properties, performed well, but advancements were sought. The formulation of greases with better adhesion characteristics, designed to cling to metal surfaces even in the presence of water, became an area of research for lubricant manufacturers. The constant battle against rust and corrosion on metal axles and bearing races was another driving force behind improved lubrication. By the 1970s, the American supermarket was a highly refined machine. The proliferation of chains and the consolidation of retail power meant that standardization of operations, including maintenance, became more desirable. Cart manufacturers, now producing hundreds of thousands of units annually, often provided clearer recommendations regarding lubrication. They might specify the type of grease to use, the frequency of application, and even the exact grease fittings to be utilized. This helped to professionalize the approach to cart maintenance across the industry. This era also saw a greater emphasis on the specific needs of different axle components. The front swivel casters, with their dual axes of rotation, the wheel rotation and the swivel rotation, generally required more frequent and meticulous lubrication. These components were often equipped with multiple Zerk fittings, one for the wheel bearing itself and another for the swivel bearing, which allowed the wheel assembly to pivot. The fixed rear wheels, often simpler in design, might require less attention, or might even be equipped with permanently lubricated, sealed bearings as a cost-effective measure. The types of grease available expanded further. While lithium complex greases remained dominant, specialized high-temperature or extreme-pressure (EP) greases, often containing additives like sulfur-phosphorus compounds, began to appear. While high temperature wasn't typically a major concern for shopping cart axles, EP additives offered enhanced protection against wear under heavy loads or shock loading, common occurrences with overloaded carts. The choice of grease was increasingly influenced by economic factors. The balance between the cost of the lubricant, the labor involved in application, and the extended lifespan of the components. The method of lubrication itself saw minor refinements. While the lever-action grease gun remained standard, advancements in nozzle design allowed for better sealing with Zerk fittings, reducing leakage and ensuring more efficient lubricant delivery. Some maintenance operations experimented with pneumatic grease guns, which used compressed air to dispense grease, offering faster application and reducing operator fatigue, especially in large fleets. However, the cost of pneumatic systems and the need for air compressors meant they were not universally adopted, often reserved for larger chains or dedicated maintenance facilities. A subtle but important consideration during the 1970s was the environmental impact of lubricants. While not yet a dominant concern, the disposal of old, contaminated grease and the potential for new grease to leach into the environment began to enter the periphery of discussions. Biodegradable lubricants were nascent, far too expensive for widespread shopping cart use, but the principle of responsible material management started to take root. This meant greater care in collection of spent greases during overhaul or replacement. The 1980s brought further consolidation in the supermarket industry and a relentless focus on operational efficiency. The shopping cart had matured into a highly engineered product. Manufacturers were continually refining wheel and axle designs to improve durability and reduce maintenance requirements. One significant trend was the increased prevalence of fully sealed, precision-engineered bearings, particularly in the front swivel casters. These bearings were designed to be truly lubricated for life, aiming to outlast the typical lifespan of the cart itself. This meant that for a growing proportion of new carts, the need for periodic axle lubrication by supermarket staff was diminishing. However, a vast fleet of older carts still existed, many of which relied on traditional greasable components. For these carts, and for any newer carts that still incorporated grease fittings for specific components, the standard lithium complex greases continued to be the preferred choice. The 1980s also saw the development of more stable and refined thickeners for greases, leading to even better performance characteristics, such as enhanced shear stability and resistance to oxidation over time. Synthetic greases, while still largely cost-prohibitive for common shopping cart applications, demonstrated the technological capabilities being developed in the lubrication industry. These advanced formulations offered superior performance across extreme temperatures and loads, but their adoption for shopping carts remained minimal due to economic considerations. The maintenance schedules became even more stringent in many chains. Computerized maintenance management systems, CMMS, began to emerge, allowing for more systematic tracking of assets, scheduling of preventative maintenance tasks, and management of spare parts inventory. This meant that the lubrication of shopping cart axles, when required, was integrated into a larger, more sophisticated maintenance strategy. Data could be collected on the average lifespan of wheels with different lubrication frequencies, helping managers optimize their maintenance budgets and practices. Training for maintenance personnel also continued to evolve. With a mix of older greasable carts and newer, sealed-for-life units, technicians needed to understand which components required attention and which did not. Manufacturers' manuals became more explicit, often including detailed diagrams indicating lubrication points and recommended lubricants. The proper use of the grease gun, including knowing when not to over-lubricate a sealed or partially sealed bearing, became an important distinction. Over-greasing could lead to seal damage, lubricant leakage, and ultimately, premature bearing failure. The less is more principle, or more accurately, the just right amount principle, was emphasized. The economic pressures of the 1980s also drove kart manufacturers to innovate in ways that reduced maintenance burden for their clients. The goal was to provide a kart that required minimal intervention from the supermarket once purchased. This meant exploring new materials for wheels, such as polyurethane, which offered better durability and quieter operation than traditional rubber or hard plastic. These materials, combined with precision-sealed bearings, significantly reduced friction and the associated need for external lubrication. The evolution was subtle, almost imperceptible to the shopper, but profoundly impacted the daily routines of supermarket maintenance staff. As we approached the 1990s, the landscape of shopping cart axle lubrication had transformed considerably from its origins in the 1940s. The predominant trend was towards maintenance-free components. Many kart manufacturers had successfully integrated fully sealed, permanently lubricated bearings into their wheel assemblies, particularly for the critical front swivel casters. These bearings were designed to operate reliably for the entire expected lifespan of the cart, thereby virtually eliminating the need for periodic grease application by supermarket staff for these specific parts. However, the transition was not absolute. Many supermarkets still operated mixed fleets of carts, including older models with greasable components. For these legacy carts, the lubrication practices refined over the preceding decades continued. Lithium complex greases remained the industry standard for general-purpose application, valued for their balanced performance characteristics, cost-effectiveness, and broad availability. Where specific challenges arose, such as exceptionally wet environments or heavy loading, more specialized greases with enhanced water resistance or extreme pressure additives might be selectively employed. The method of application, for those components still requiring it, largely remained the use of manual, lever-action grease guns. While pneumatic grease guns offered efficiency benefits, their higher initial cost and the need for compressed air infrastructure meant they were typically only found in very large distribution centers or dedicated maintenance depots serving multiple stores. For the average supermarket, the reliable, inexpensive hand-operated grease gun continued to be the workhorse tool. The emphasis remained on precise application, ensuring fittings were clean before greasing, applying just enough lubricant to purge old grease and provide a fresh film, and avoiding overpressurization. Standardization reached a higher level in the 1990s. Major supermarket chains often had detailed maintenance manuals that specified exact lubricants, tools, and schedules for their entire cart fleet. Cart manufacturers, in turn, continued to refine their designs, often specifying no lubrication required for their latest models, effectively shifting the burden of lubrication away from the end user. This represented a significant evolution from the early days where lubrication was an afterthought or an ad hoc fix. Now, the design itself often accounted for lubrication, either by making it permanent or by making it an integrated, low-frequency task. Environmental considerations also began to play a slightly more prominent role. While not yet driving widespread adoption of fully biodegradable lubricants for shopping carts due to cost and performance trade-offs, there was a growing awareness of proper waste disposal practices for used greases and oils. Regulations on hazardous waste disposal also became more stringent, encouraging responsible management of maintenance byproducts. The subtle evolution of axle lubrication methods in American supermarkets from 1940 to 1990 is a testament to how even the most mundane operational details undergo continuous refinement. What began as an informal reactive process of dripping oil or smearing grease evolved into a sophisticated interplay of material science, mechanical engineering, and maintenance management. From basic petroleum oils and manual application, we saw the introduction of Zerk fittings and grease guns, the widespread adoption of lithium-based greases, the emergence of sealed bearing technology, and the integration of preventative maintenance schedules. Each step, though incremental, contributed to more durable, smoother-rolling shopping carts, which in turn enhanced the customer experience and reduced operational costs for supermarkets across the nation. The initial challenge in the 1940s was simply keeping the rudimentary wheels turning. The axles were often plain steel shafts rotating within simple bushings, susceptible to wear, corrosion, and the accumulation of debris, lubrication was, at best, a temporary fix. Imagine the crude nature of it. A shop assistant, perhaps during a lull in customer traffic, grabbing a generic can of oil from a back shelf. A few haphazard drops might be applied to the outer edges of the wheel hub, where the axle was visible. This oil would almost immediately begin its slow migration, drawn away by gravity, flung off by rotation, or absorbed by dust. The brief respite from squeaking would soon give way to the familiar complaints. Grease, if used, presented its own set of issues. A glob of thick, often brownish grease might be packed by hand into the wheel well. This was often more effective at trapping dirt than it was at penetrating the tight clearances required for proper lubrication. The absence of specific lubrication points meant that the efficacy of such efforts was highly variable. By the late 1940s and early 1950s, as shopping carts became more sophisticated and their use more widespread, the limitations of these early methods became a growing concern. The sheer volume of carts in a busy supermarket meant that a single squeaky wheel was no longer an isolated incident, but a systemic problem. Worn-out axles and seized wheels meant carts were constantly being taken out of service, requiring costly repairs or premature replacement. This economic pressure spurred the gradual adoption of more deliberate maintenance practices. The concept of a lubricant, specifically designed for bearings rather than a general-purpose oil, began to take hold. Grease, with its ability to adhere to surfaces and resist being squeezed out under pressure, increasingly became the preferred choice over oil for the static or slow-moving components of the axle. The Zerk fitting, previously mentioned, played an absolutely pivotal role in this evolution. Its design, allowing for high-pressure injection of grease, meant that for the first time, lubricant could be delivered directly to the heart of the bearing or bushing, ensuring thorough coverage and purging old contaminated grease. This transformed lubrication from an external application to an internal process. The grease gun, initially a robust if somewhat cumbersome tool, became indispensable. Maintenance workers had to learn the technique, coupling the gun's nozzle to the fitting, depressing the lever with controlled force, and feeling for the subtle resistance that indicated the bearing cavity was adequately filled. Overgreasing was a common initial mistake, leading to blown seals or wasted lubricant, highlighting the need for experience and informal training. The choice of lubricant itself also grew in importance. While basic calcium greases were cheap and readily available, their performance limitations in terms of water resistance and temperature stability became apparent. In the typical supermarket environment, carts were exposed to a range of conditions. The dry warmth of the store interior, the dampness of a rainy parking lot, the cold of a winter sidewalk. A lubricant needed to perform reliably across these varied scenarios. This is where lithium-based greases began to truly shine in the 1950s. Their improved mechanical stability meant they held up better under the constant rolling and swiveling forces. Their higher dropping point ensured they wouldn't melt and run out in warmer conditions. Their superior water resistance meant they offered better protection against corrosion, a constant enemy of steel axles and bearings. The evolution of the shopping cart itself also subtly influenced lubrication methods. As carts became more specialized, with dedicated front swivel casters and fixed rear wheels, the lubrication requirements diverged. The swivel casters, being the most maneuverable, and therefore subject to the most complex stresses, typically had more lubrication points and required more frequent attention. These casters often incorporated thrust bearings or similar mechanisms to facilitate smooth pivoting, all of which required careful lubrication. The fixed rear wheels, with their simpler rotational motion, often had less demanding lubrication needs, sometimes being factory sealed or requiring less frequent greasing. Throughout the 1960s, the drive for greater efficiency and reduced maintenance costs led cart manufacturers to experiment with new bearing designs. While fully sealed bearings were still some way off for widespread, cost-effective application in all parts of a shopping cart, shielded or partially sealed bearings became more common. These offered a compromise, better protection against contaminants than open bearings, while still allowing for periodic re-greasing through a Zerk fitting if necessary. The presence of shields or partial seals meant that lubricant retention was improved, extending the intervals between maintenance. This also necessitated a more nuanced understanding from maintenance technicians. Not all sealed bearings were truly lubricated for life, and some still benefited from targeted re-greasing. The formulation of greases continued its slow, steady advancement. Additives like rust and oxidation inhibitors became standard, further extending the life of both the lubricant and the metal components. The consistency of grease, measured by its NLGI grade, National Lubricating Grease Institute, also became a factor. Most shopping cart applications typically utilized NLGI grade 2 greases, which offered a good balance of pumpability through grease guns and adherence to bearing surfaces. A grease that was too thick might be difficult to pump, while one that was too thin might not provide sufficient protection or retention. This level of detail, though technical, was gradually understood and implemented by those responsible for maintaining supermarket fleets. The rise of larger supermarket chains and the adoption of more formalized maintenance programs in the 1970s brought a degree of standardization that had been absent in earlier decades. Chains often developed their own internal manuals, detailing everything from daily cleaning procedures to quarterly cart maintenance. These manuals would often specify the exact brand and type of grease to be used, the specific lubrication points on their various cart models, and the frequency of application. This moved away from individual store managers or handymen making arbitrary decisions towards a more corporate-driven, consistent approach. The goal was uniformity of experience for customers across all stores in a chain and predictable maintenance costs for the corporation. The tools also saw subtle improvements. While the basic lever-action grease gun remained fundamentally unchanged, accessories began to proliferate. Different nozzle types were developed for hard-to-reach fittings. Flexible hoses replaced rigid pipes on some guns, offering greater maneuverability. Bulk grease loaders allowed for faster refilling of grease guns from larger containers, reducing waste and mess. These small innovations collectively contributed to a more efficient and cleaner lubrication process, lessening the chore for maintenance staff. The choice between purchasing grease in small cartridges or larger bulk containers also involved economic calculations, with larger operations often opting for bulk to achieve lower per-unit costs. The durability of shopping cart wheels and axles became a major selling point for cart manufacturers in the 1980s. A cart that required less maintenance was a more attractive product to a supermarket chain. This spurred further investment in research and development for bearing technology. The fully sealed, lubricated for life bearing became the gold standard. These bearings often incorporated synthetic rubber seals that were highly effective at keeping contaminants out and lubricant in. The lubricant itself, often a high-quality lithium complex or even a synthetic grease, was carefully selected and factory-filled to last for tens of thousands of cycles under typical shopping cart loads. This was a significant shift. Instead of lubricating, the task became inspection and eventual replacement of the entire wheel assembly when its lifespan was exhausted. However, the reality for many supermarkets in the 1980s and into the 1990s was a mixed fleet. They had their brand new, state-of-the-art carts with sealed bearings alongside older models that still required traditional greasing. This meant maintenance staff needed to be versatile, capable of identifying which carts had grease fittings and which did not. It required a keen eye during inspections to determine if a sealed bearing was failing, often indicated by excessive play, rough rotation, or noise, versus a greasable component that simply needed more lubricant. The transition was not instantaneous, but a gradual phasing out of older technologies, with lubrication methods adapting accordingly. The economic pressure to extend the life of existing assets also meant that for many older carts, thorough and regular lubrication remained crucial. For these carts, understanding the nuances of grease properties was still important. For instance, in supermarkets located in coastal areas, a grease with superior corrosion protection might be preferred due to the higher humidity and salt exposure. In areas with extreme temperature fluctuations, a grease with a broader operating temperature range would be beneficial, These subtle choices in lubricant selection, though perhaps not explicitly decided at the store level, were often guided by regional or corporate maintenance guidelines. The process of lubrication itself, in its fully developed form for greasable axles, involved a meticulous sequence. First, the cart would be moved to a designated maintenance area, often a corner of the stockroom or an outdoor covered bay. The wheels would be inspected for obvious damage or excessive wear. Any visible dirt or grime around the grease fittings would be wiped clean to prevent contaminants from being forced into the bearing. The grease gun, loaded with the appropriate NLGI Grade 2 lithium complex grease, would be carefully attached to the Zerk fitting. With a steady hand, the technician would pump the lever, feeling for the pressure buildup. For a wheel bearing, a few pumps might be sufficient, just enough to see a slight bead of fresh grease emerge from the seal, indicating that the old, potentially contaminated grease had been purged. For a swivel bearing, which might be larger and have more internal volume, a few more pumps might be required. The goal was always to achieve proper fill without overpacking. Overpacking could lead to seal damage, increased friction, and even bursting of the bearing, negating the entire purpose of lubrication. After lubrication, the wheel would be gently spun by hand to ensure smooth operation and to help distribute the new grease evenly. Any excess grease would be wiped away, not just for cleanliness, but to prevent it from attracting dirt and grit, which could then migrate into the bearing. This entire process, repeated across dozens or hundreds of carts in a fleet, represented a significant investment in labor and materials, yet it was a critical one for maintaining the functionality and longevity of these essential retail tools. The subtle evolution of standardized grocery store shopping cart axle lubrication methods, spanning from 1940 to 1990, is a fascinating microhistory of industrial pragmatism meeting technological advancement. It demonstrates how seemingly insignificant details, when scaled across an entire industry, can drive substantial innovation and refinement. From the haphazard oil drip of the early supermarket to the precision-engineered, lubricated-for-life sealed bearing, the journey of the shopping cart axle is a quiet testament to the continuous pursuit of efficiency, durability, and a smooth, almost silent customer experience. It's a story not of dramatic revolutions, but of consistent incremental improvements, each adding a layer of sophistication to an object we often take entirely for granted. As the 1990s drew to a close, the focus had largely shifted from how to lubricate to whether to lubricate at all, with newer designs aiming to make the question largely obsolete for the end user, thus marking a significant milestone in this humble but vital aspect of supermarket operations. The quest for silent, effortless movement, a pursuit spanning 5 decades, had reached a point where the solution was often built into the very fabric of the wheel itself, rendering the grease gun an artifact for an aging fleet rather than a tool for the newest arrivals.